This is a joint presentation by Mike Black and I will start us out. So if we could. Our premise is that partnerships can create the evidence base for addressing climate resiliency in Arctic regions of the circumpolar north, and success in these countries will hold lessons learned and knowledge of best practice for adaptation to changes in the environmental conditions driven by climate change. So as you've seen in this World Congress of Epidemiology so far, the Arctic is a very special region. It's in the circumpolar north, and the issues facing indigenous people aren't just issues for Alaska Natives. The essential resources, some of these you've heard of before, the WHO and the World Meteorological Organization, and professional associations. There's a real role for organizations like the IEA. And federal, state, local, and other tribal agencies are all involved, non-governmental organizations, and the Arctic Council is currently chaired by Canada, US next year. And this is very important because as we've heard with IPCC report, there are lots and lots of stakeholders and lots of review steps. So we're going to talk about why Alaska's at the coalface, the impacts and opportunities in the borough, a little bit on the demographics, why adaptation is essential and mitigation looks far beyond regional capability, the statewide energy planning needs integration, and the challenges ahead. So what do you treasure? Our focus here is healthy, sustainable Alaska Native communities and Alaska Natives and the state of Alaska, the last great frontier. And the goal in rural and remote Alaska is to provide utilities on a sustainable basis, allowing for full coverage of operation and maintenance costs. So the Northwest Arctic Borough is that portion that's above the Northwest Arctic Circle. So that's 66 degrees, 33 minutes you can see there, and it's known as the Arctic, and the zone just to the south is called the Northern Temperate Zone. So this is all America's and Alaska's portion of the Arctic, and in the Circumpolar Health Talk this morning, the 8 countries in the Circumpolar North were mentioned. I'll let you see those yourself. So where we're going with this is engineers, epidemiologists, and environmental health practitioners can contribute to the design of healthy, sustainable communities and improve the quality of life for populations through collaborative research and practice. That's been our theme throughout the plenary and symposia here. There's plenty of resources here. We've gotten exposed to a lot of them in this meeting. And you have folks here from ANTHC, just 2 of them on this panel alone. The universities are also involved, the University of Alaska system. We heard about that in the opening session from the Chancellor Case. And there's academic researchers all across the U.S., places like Columbia, Dartmouth, Tufts, others. There's a lot of research going on. And the U.S. Arctic Research Commission is based here. And the people of Alaska are really the key stakeholder. Our portion of the Arctic, this is some of the environmental conditions that are changing that are important are the conditions, the picture was shown of Shishmaref, but Shishmaref, Kivalina, Selawik in the Northwest Arctic Borough, these were all mentioned as places to keep an eye on. There are others like Newtok, where they're actually in the process of relocating. And there was a cost estimate we heard from Ingomar, which is shocking given population numbers and things. This is the region. That's where it is in relation to the whole of Alaska. Alaska is about the size, 1/6 the size of the whole lower 48, and this green area is bigger than the state of Indiana. So it was formed in '86, 11 communities, roughly the size of Indiana, regions remote and isolated, no connecting roads, 85% of the residents are Inupiat Eskimos. So you can see the unemployment rates. Ingomar mentioned the problem with incomes and low population numbers. And so that's just a little bit of the demographics. Some of this we may have touched on earlier. That's Kivalina on the top and Kayana on the bottom. Environment's changing. What are the challenges for the NAB? Affordability, sustainability of infrastructure, management capacity and capability, proper and efficient operation and maintenance, providing a proper operating environment for energy, water, and wastewater treatment services, the water source and system type effect costs, and there's a variety of environments in Alaska. Alaska is 375 million acres, so we have incredible diversity and biodiversity and changes here. Hard to realize sometimes. And how do we realize health goal benefits moving towards sustainable communities? We want resilient, sustainable, healthy communities. So here's the dilemma. The Arctic's changing. Adaptation focuses on things that we got to do immediately in the short term and longer term, balancing development and stewardship of resources. And Alaska's kind of seen as an owner state. The resources are for the benefit, the development and stewardship of the resources of the people of the state of Alaska, and that's a balancing act. Whereas mitigation has to focus on addressing root causes of problems, as does epidemiology with diseases and mortality and morbidity. Energy development based on burning fossil fuels has exacerbated the problem. So if we ignore that, the problem is just going to get worse. And another problem is that our revenues must meet or exceed expenses in providing this important water and sanitation services. And the decision makers must have a long time horizon, decades, rather than be measured by quarterly profits. So we tend not to think about what's going to happen in 2050 or 2100. It's very uncertain. And some of the effects of climate change, there's this lag period. So principles in tackling climate change: subsidies are a fact of life and distort a level playing field. Before statehood, there's always been these ideas of mega projects, big projects like the Rampart Dam, Susitna, Watana Canyon, Susitna, Devil's Canyon, and Susitna, Watana are other examples. The key to better sustainability is economic viability and financial feasibility, and projects have not only passed these tests, but some of them have. We've invested in over $300 million in a coal-fired clean coal project that has never generated output. The paper just 2 days ago talked about Kabata, the Nick Arm crossing, and whether or not it could generate enough revenues to be even remotely viable. So we have this mentality of big projects, but a fact of life is we depend a lot on subsidies, as was mentioned in Southeast Asia, that subsidies are a problem for fossil fuels. And one cannot wait for a disaster like severe storms or until the end of the 21st century to solve these dilemmas. So here's another example, another picture of Kivalina and another picture of Selawik. So hopefully at this point, these two communities are on your radar screen. And renewable energy resources, Ingemar mentioned those, their importance. They don't generate the kind of emissions that burning diesel fuel does. So one measure of success of renewable energy is how much diesel fuel you don't have to buy. And we have programs in the state of Alaska with a Renewable Energy Fund and with energy efficiency programs. So I'm going to kind of skate through this very fast because the important take-home message here is that energy data shows that energy expenses of water and sewer per capita are very expensive for different kinds of systems. And this is an economic problem. So the health impacts of water and sewer, Mike, I'm going to turn it over to you at this point for this particular slide, and I'll load up some things so I'm not going too far away.
Okay, what is the greatest improvement that's been made for the public health in the villages? What do you think is the greatest effort that has paid the greatest dividend for public health? Piped water and sewer. Now, piped, I don't mean to say that's the only solution, but dealing with human waste and providing clean, treated water has the greatest benefit now of all the things we've ever done. However, it hasn't come at a very cheap price. Building in a permafrost, high water table environment with extreme cold means that any machinery has to be extremely robust. And frankly, with federal government funding the majority of those costs, with the state of Alaska participating in it over the last 20 years, there's been over $2 billion invested in rural Alaska to build those systems. It gives us a great deal of alarm at Alaska Native Tribal Health Consortium to consider how fragile those systems are and that they need to be operated by a community of oftentimes less than 500 people with very little income and with extremely high costs, especially as Ingemar points out, the energy costs alone. You could imagine an Arctic water and wastewater system requires a lot of energy to keep water from becoming solid in those pipes. So this is an extremely important part of trying to keep the health benefits for these communities and do so with a way that allows them to function and continue to function and be supported by households with very limited incomes. Now, let's take that environment and then impose upon that climate change. Climate change affects everything about how well or how poorly things are operating in the community. Pipes allowed to sag because of melting permafrost represents a low area where water can accumulate and freeze. That can stop the entire system from operating. So the health impacts of water and sewer needs to be preserved through a number of steps, one of which is we better look at our designs, our methods of construction, and try to improve those, recognizing that what is now solid ground may not be solid 5 years, 10 years, or 15 years from now. What else? We better recognize, as you could see in the slide about the thermokarst, the large amount of sediment that is entering the water, the surface water stream, that would require filtration. And filtration in these small community systems would require a lot of labor because you'd be changing filters frequently to keep that system from becoming completely clogged with sediment. Well, anytime you increase the operational cost through, for example, labor, then the households have to pay more money. So this is going to be a challenge. The slide here shows you something called ARUC. We call it ARUC. It's an Alaska Rural Utility Collaborative that is operated by Alaska Native Tribal Health Consortium. We have 28 communities that we operate the water and sewer system for. So we are intimately familiar with the problems of operating, managing, and paying for the operations of the systems. And it is a challenge in the best of times. It may become an unsustainable challenge as we have climate change express itself more clearly. So, what are we talking about climate change in Alaska? I think here I want to point out a slide. The state of Alaska 8 years ago began a process of actually trying to plan for climate change. I would love to report to you that the state of Alaska has made 8 years of progress, but it hasn't. Because of the political consequences of the term climate change, the state of Alaska abandoned its efforts at trying to address climate change through a group of interdisciplinary team, including the University of Alaska. Now, it's ironic that the most robust efforts in trying to deal and plan for climate change were being done under then Governor Palin. And now, because of the importance of the oil industry in the state of Alaska and other things, those efforts are much less robust, let's say. But this webpage in this slide, I would recommend everyone go to Google, if you will, climate change in Alaska, and you will get this website. It identifies a number of efforts that were made at that time and the data and information and fact-finding that was being accomplished. and it has a number of interesting things in it. I just so happened to participate in this process at the time, and I was actually involved with what's called the Immediate Action Work Group, which was attempting to address the impacts on communities of climate change, including erosion, flooding, seasonal flooding along the coast because of the lack of shore-fast ice, relocation of communities such as Newtok, and others. And I believe that you're going to, by looking at this website and reading some of the reports that you can find there, you will get a very good picture, although it will be 5 years old, about what was happening in the state of Alaska and what needs to be done in order to address climate change in the future. And really what it is we need to adapt. And because native villages now are so full of infrastructure that can't be moved, or it's difficult to move, adaptation will not be as easy as it was 100 years ago. It will take a great deal of coordinated effort by lots of organizations with the community to actually be able to put in place the adaptation techniques that we need in order to deal with climate change. So Steve, do you want to take over now? Okay.
Again, I'm just going to rock and roll through these. I think it should be obvious at this point that there's a role to be played by epidemiologists and environmental health practitioners and engineers and others. We need research needs. Part of this website shows that was a specific task that was given to these groups. Opportunities and challenges for future research, there's plenty, and Professor McMichael in that previous slide presented us with some of those, how we do adaptation, whether we not, call things mitigation or we think about it in terms of systems thinking. We need new ideas and ways of tackling this that are going to be effective. We've seen paradigms from Southeast Asia and other things that are really helpful tools, and we need lots of experiments so that we can find a way and use the lessons learned to go forward, and best practices. And One Health is a possible unifying theme that has to do with environment and biodiversity and ecosystem services, and it's consistent with traditional Inupiaq values up in the Northwest Arctic Borough. And I'd like to acknowledge Commissioner Hardick, who shared some information with me in several meetings. So there's the take-home messages of the key elements. We need research and applications. We need to integrate capabilities and work across teams, across organizations. And we need to implement policies, programs, plans, and projects that will lead to more sustainable communities. So we don't quite know how to do all of more sustainable utilities yet, or deal with all of these problems like permafrost thawing and the problems that you've seen, but we know they're real issues on the ground. And so high energy prices are a threat. And the time for response is now. This is a real immediate concern. Some communities, relocation is a necessity, and mitigation prospects are dim. Emission of greenhouse gases and dependence on carbon-based fuels continue. So we can't plan for a future like that if we want healthy, sustainable communities. Mike, I'm going to have you rock and roll through this because I want to leave Dr. Jackson with the podium here. So.
Okay, so this will be very quick, but what we want to do is take a little tour of the Northwest Arctic and look at some of the water and sewer issues in relation to climate change. Obviously, the importance of water and sewer and piped water has been well documented. Most of the health data that Dr. Berner or other individuals at ANTHC could quote this completely, that water and sewer has a positive impact on public health. If we look at sanitation utilities in the north, they come in three different varieties primarily. There are obviously individual haul, that is the households responsible for going down in the river or using ice melt and whatever to get water to be able to be used. We have a community haul system, which is where the government, the tribal or city government, provides a operator to move water to the household in tanks. They're either pulled by snow machine or by four-wheelers, as we call them. And then, of course, there's also the piped distribution and collection of water, and then a collection of waste. This would be the ultimate as far as its use in the household. We know that the water is changed, or the temperatures are changing, both in the groundwater as well as the temperatures. We know that the water quality is changing, and this is happening in part because saltwater intrusion into some of the areas, also the high levels of sediment in the rivers. Also, as it warms, we're getting algae and other growth in the river that weren't formerly seen. We also finding, as it was shown earlier in the slide, that tundra ponds that are often used for water are drying up in some cases. So we know that there's changes. This is a picture that shows you what one of those changes is. Anytime you put pipes down, they are at risk. So here we have the community of Kotlik, where they lost their entire water and wastewater system to shore ice being pushed up by storms in the fall, and that acted as a battering ram to take the pipes completely out of the community. We also know that there's flooding in the typical treatment system for rural Alaska is a lagoon system. Often that's an impoundment where human waste is collected. Over a period of time that is discharged. Now, what we're seeing in many communities is that those lagoons are susceptible to flooding and erosion. If the dikes are eroded, obviously the human waste can't be contained. This is true also of the solid waste sites. We often talk about landfills, but in villages, the high groundwater basically makes a landfill simply a diked lagoon where solid waste is disposed of. This can be obviously a problem, and especially as permafrost starts to melt, that contamination can enter the groundwater. We can also see that, for example, with haul systems, that any transportation system, in this case you can see a picture of a boardwalk, which is placed there because the tundra is so soft that no other way could any weight be put upon it without creating a problem. So in this case, this boardwalk has been displaced by water that is flooding, and that makes these haul systems in some of these communities impossible to maintain. We see that obviously anytime you get the water and sewer system compromised, you're going to have problems with public health. Not form on the shoreline as quickly as it normally did. What happened next was our storm season begins in October. The ice had not completely formed. If it had, it would have dampened the waves as they came ashore. In this case, they were just forming ice, so the ice broke up and became battering rams. The only thing that really saved the housing in this community was, in fact, the water and sewer pipe, which stopped the ice from being pushed further up into the community. But in the process, you can see the square, that's a utilidor with water and sewer pipe, and it took the brunt of the damage. We can look back over the last 10 years and 10, 15 years, and we see time and again events occurring more frequently that have to do with climate change. And in fact, I didn't even populate the period of time between 2005 and 2013, but there have been many events. Galena, Kotlik, Nunamikwa, you just keep talking about it. Every native villages show up as being impacted by climate change almost yearly, if not yearly. What can we do about it? Well, we have to make some changes. Adaptation is one thing we can do. We talked about Kivalina. Right now, we're currently working on this water and wastewater approach. That is a rainwater catchment area approach with a separator toilet that would separate solids from liquids and allow the liquids to be disposed of on the ground in the gravel while the solids are used. Actually, what we're proposing is using them as a compost. So this is one approach to adapting to climate change. In Kivalina, the community could never afford a piped water and sewer system, plus it's being in a threatened site, so it would never get the funding. So that's the separator toilet. Let's look at adaptation in Selawik. The far left picture is the pipe actually having been torn off of the side of the house because of differential settling of the house and the pipe. Because they are anchored at different depths, the permafrost melts, the pipe starts to sink in relation to the house being at a deeper piling depth actually stays still. So anything attached gets torn off. On the far right picture, you see that pipe there that's been laid out, and the blue is actually a flex pipe, which allows for differential settling. Here is another concept of adaptation in Kotlik, where we're bringing back and we're putting the replaced pipes from that disaster on pilings that will set it above where the ice would actually impact it. Here's Newtok. It's adapting by relocating the old village on the left, the new village on the right. Finally, adaptation in the North Slope, where we see the melting ice cellars where the food such as whale meat and others is being compromised because the ice is warming up and the food becomes spoiled. So on that plan set that you see right there, ANTHC developed a refrigeration program using solar arrays to keep the ice cellars intact during the summer. Obviously, sunshine is not an issue on the North Slope at that time. Look, here you see, this is an example. This is an engineering parameters, design parameters that are used by every certified engineer when building something. What you see in that chart is things have changed. Temperatures have changed, rainfall has changed, snowfall has changed. If you don't build to those changed criteria and you can't project them out, you'll be building infrastructure that by design will fail. So what we're saying is that we all, certainly engineers, need to recognize the changes. Anyway, we know that the built environment is compromised by climate change, and in that built environment compromise, public health is as well. We've got to do some things. We've got to monitor. We've got to change the design parameters, as I said, and we have to plan and work together more closely.
My goodness, this is overwhelming. And the problems we've created with 20th century solutions, whether they're chemical or fast food or ski-doos or whatever it is, have really in some ways backfired so profoundly. I apologize for telling a Los Angeles story to start with, but because that's where I am, and it has you'll see it has a relevance in a way. I was look closely at the precipitation levels there, Mike, and I had forgotten it's a desert. It's 10 to 20 inches of precipitation a year. And that's some good news, but it probably needs, we have to really think about that one. What's happened in the southwestern United States is if you raft down the Colorado River and you go past Phantom Ranch, which is at the bottom of the Grand Canyon, you can throw, a good baseball player can throw a baseball across the Colorado River right there. That river supplies Lake Mead and down to the Hoover Dam and supplies all the water for Arizona, for Las Vegas, for a third of California. It's about 25 million people. And the water levels are now so low that they're below the intakes. The water is below the intakes to supply water for Las Vegas and some of these other areas. So they spent a third of $1 billion drilling new penstocks, or whatever the proper term is, to get the water out of there. And it's not going to work for that long because we're in a drought all through the Rockies, and the same thing is happening in the Sierra, where we're not getting the water from the north. Los Angeles spends, and I'll get the relevance of this in a minute, Los Angeles spends $3 billion a year bringing water in, and it rains all winter long, hopefully, and we spend $1 billion a year running the water out, these huge concrete culverts that you might have seen in the movie Terminator, where Schwarzenegger is riding the motorcycle up and down these concrete culverts. It's absolutely crazy. And so a number of the groups in LA, and there's a group called Tree People, are positing, and people are really beginning to adopt this, is capturing water on site. So, for example, in a number of schools in Los Angeles, they've ripped up the concrete parking lots, the asphalt parking lots. They've put in large cisterns where the water that's coming off the roof, the water that's coming off the play areas, when it comes down, in your area it would be melting, and you're capturing it in a preserved area. And if we captured a good portion of the rain we got in Los Angeles during the winter, we could supply all of our water needs without spending $3 billion bringing it in from someplace 500 to 1,000 miles away. What's the relevance of this story? I don't think 20th century solutions of bringing water from far away that's subject to sea ice and subject to, it's very, very expensive, and it fails intermittently, is going to work. There are 21st century engineering challenges. I mean, we've got astronauts flying around planet Earth and drinking their own urine, and we have got to figure out how we can create places, enclaves, human enclaves, that capture those 10 to 20 inches of rain, capture the sunlight and wind power that is going by, that captures the waste that's coming out of people, that is very scrupulous about the solid waste as well, is creating methane or whatever fuel you can get from the biosolids that are coming out. Yes, you have to refrigerate, and I suppose if you go down deep enough, do you get cold or not with the thawing out, or does the earth get warm enough as you go lower? Do you lose the refrigeration benefits? I just don't know, but could one engineer that? So I'm not making this up. In China, they're building buildings that are virtually energy neutral, that are water neutral, that are capturing their sunlight, and you know, if in 1980, the United States, under Jimmy Carter, and I'm not making this up, we were spending $10 billion a year in research on energy. When President Reagan came in, and all of a sudden we had a lot more oil, we cut that down to nothing. And if we had continued that kind of research into energy, we would have batteries that, you know, you can run a Prius with a battery about this size, but if we had been doing energy research on batteries, you'd have a battery the size of a lunchbox that would power your Prius to go 150 miles. You could put it in your house, you'd capture the summertime sunlight, and you could do it. So I think in some ways, looking back and thinking we're going to solve it with 20th century solutions, we've got to, so $350 billion went into building a coal plant that generated no energy, that I figure is serving 35,000 people. That's $10,000 per person. That's a lot of money for a community of 200 people at $10,000 a person. Maybe thinking about 21st century solutions. And my other quick suggestion, I say this humbly, is, and I've been in lots of communities around the United States, when communities and people of goodwill and good heart are given the chance to really think through issues and are supported to think for the long term, supported to think about what's best for their kids, the solutions are often remarkable. There's a lot of wisdom in a community. And you know, some guy from Los Angeles doesn't have the answer by any means, but clearly we've got to look forward and not try to we have to undo the past in lots of ways, but we've got to give our children, our grandchildren, a world that really works for them. So I apologize. I hope that isn't the Greek word hubris, where the outsider thinks he knows what he's talking about. But I just felt overwhelmed as I listened to these issues, and I think we've got to look forward. Oh, so now we have to, you're the moderator. So.
Well, what I'd like to do now is just very quickly, well, let's thank Dick for his comments as a respondent. I'd like to show you these. You probably can't see from where you're sitting, but ANTHC has done these climate change reports that I was sharing with Professor Jackson. That one's on Kivalina. This one's on Selawik. I have one on Noatak here. These are all out of these 11 villages. You can see that Cayenne is another one. Point Hope is another one. So there's a lot of work that's been done to document conditions on the ground. Jim Berner gave us a really good overview of these biomonitoring and other programs like RAMP. And I did want to close with one thing. I had invited Professor Hensley to come address us, and so I have a little statement out of his book. So I've been taking Alaska Policy Frontiers the last 3 years. I go every year because I'm not smart enough to get everything out of the class in just one go. But he invites speakers to come and talk. And this is out of the epilogue of his book, and this book is 50 Miles from Tomorrow. And he's a Nupiat. And this comes at the end of his book, where he describes his life, and he describes the traditional values and the culture and a lot of things we've heard about indigenous people and the history of Alaska and fighting for land rights and what a special place this is, and sharing and subsistence and foods and hunting. And he says, and I quote, this is out of page 231, "The key is to maintain our identity, our values, and our spirit. And the key to accomplishing that is in the hands of individuals, families, clans, and the elders for whom we fought so hard. Every one of us has a Nagagiak in our lives," that's his mother, "someone who gave us all he or she had. Our challenge is to preserve the memory of those who sustained us and to conserve and protect the land that fostered their time on Earth." Thank you very much for attending our climate change and health session, and thank you so much for our speakers, especially those that have traveled long ways. And thank you so much, ANTHC, Mike and Jim, for being here today. And I see Mike and the Brubaker in the audience, so it's good to have you here too. Thank you very much. This concludes our Symposium 3 this afternoon. Thank you.